Well, hello there, and welcome to Science-y Time with Noah and Jerry. Today we'll be performing the chemical reactions of copper lab. Let's launch right into the procedure. First, weigh out half a gram of copper turnings and put them in a 250 milliliter beaker. Next, pour 5 milliliters of nitric acid into the beaker. Make sure to do this under a fume hood because some nasty nitrogen dioxide will start coming off, which is flat out deadly. The solution will start turning green and eventually it will turn blue. At that point, you can remove it from the hood. Then, add 100 milliliters of distilled water. Add 30 milliliters of 3 molar sodium hydroxide and stir. The solution will turn darker and somewhat gelatinous. Now, heat the solution on a hot plate while stirring until the black substance settles to the bottom of the solution and the liquid turns clear. If any of the liquid remains blue, add more sodium hydroxide. Now, get ready for this next clip because it's a doozy. Oh gosh, where was I? Ah yes! Decant the clear liquid by placing the stirring rod as shown and pouring down the sink. Add 200 milliliters of hot distilled water, stir, allow the precipitate to settle, and decant yet again. Add 15 milliliters of 6 molar sulfuric acid and stir. The solution will eventually turn a pale blue. Add 2 grams of 30 mesh zinc metal under the fume hood. If the solution is still blue after gas stops coming off of it, then add small amounts of zinc. Decant once again. Add 20 milliliters of 6 molar hydrochloric acid under the hood and allow it to react. Afterwards, add 50 milliliters of distilled water and decant yet again. Weigh an evaporating dish and transfer the solid to it. Then, add 10 milliliters of distilled water and decant. Repeat this decantation process 2 more times. Then wash the solid with 5 milliliters of acetone and decant yet again, bringing the grand total of decantations to a whopping 8. Finally, place the evaporating dish on a hot plate to evaporate the remaining water and acetone. Note that the use of a watch glass is helpful in preventing spatter, but make sure to weigh it as well. Once the evaporating dish is cool, weigh it to determine the mass of the solid. Whew! Well, that's all there is to the procedure. Now let's go over the chemical reactions that occurred in this lab. 5 chemical reactions took place in this experiment. In the first one, which was an oxidation-reduction reaction, copper was oxidized by nitric acid forming copper 2 ions. Then, sodium hydroxide was added and precipitation occurred, forming copper hydroxide, the gelatinous blue substance. When this was heated, decomposition occurred and copper oxide was formed as well as water. Next, when sulfuric acid was added to the copper oxide, an acid-base reaction took place, forming copper 2 ions and water. The final reaction was another oxidation-reduction reaction, in which solid zinc reduced the copper ions into solid copper once again. Now, let's examine the experimental results. With an initial mass of 0.4989 grams of copper and a final mass of 0.4952 grams, the percent yield, as shown by the calculations at the bottom of the page, was 99.26%, or in other words, there was a 0.74% error. Now, let's discuss the outcomes of this experiment. The objective of this lab was to put copper turnings through a series of reactions and to recover as much copper as possible. With a 99.26% yield, that objective was certainly met. As for the 0.74% error, there are a number of ways it can be explained. For one, it is impossible to decant perfectly, because identifying whether or not it is safe to keep pouring is a visual indicator. While it may appear that none of the precipitate is being poured out, a small undetectable amount may unavoidably be lost. Alternatively, when transferring the copper from the beaker to the evaporating dish, some of it may have inevitably been lost to the sides of the beaker. These sources of error would only make a minor impact, but the percent error in this experiment was minor as well. Thank you for joining us for today's installment of Science-y Time with Noah and Jerry.